Does the universe we live in have boundaries? James Webb, the telescope, has made new discoveries. His discoveries were bounced again and again, overlay our understanding of the universe for the universe, so there's a lot of talk. Some people think there was no Big Bang. The universe has no scale. It's infinite. Stars in the universe, all celestial bodies and matter such as planets are also infinite. Others believe that the universe is similar to the human body. Each cell represents a galactic structure. However, scientists believe that the universe began 13.8 billion years ago with the Big Bang, but Webb's latest discovery let the Nobel laureate bring emotion to Gross. Here's a quote from him. "It will make you more confused about our universe." He said we had no conflicts or problems. From the summer of 2022, we are facing a crisis. Scientific research seems to have come to a standstill. No new discoveries, no further exploration of galaxies. Scientists around the world have encountered the former unprecedented challenges. The latest findings from the James Webb Space Telescope could revolutionize our understanding of the universe. Study understanding. Theoretical physicist, Nobel Prize winner David Gross summarize it as, "We're not dealing with a scientific problem. It's a real crisis." He could append everything we know. Since James Webb Telescope shows the first photos since the universe was young, scientists are feeling despair like never before because we may have been putting some half-truth, semi-fake information, spread it as an unequivocal fact. Now, dozens of theories are being put to the test. Do we have to accept such an unpleasant fact? We almost believed in one. 100 years of mistakes, dogma. If the Big Bang Theory is proven wrong, billions of textbooks around the world will need to be rewritten. These consequences will not only affect the Big Bang Theory itself. Other physical concepts can also suddenly become obsolete. Related to this basic dogma, we may be living in a brand new era, the beginnings of physics. Let's try again, depending on what has happened since the summer of 2022. James Webb Space Telescope. The first images of the universe were made available in July 2022. Deep space image. Here you can see the scarf, the light from the oldest galaxies captured by telescopes. The orange and red spots are the oldest sources of light. A few days after the image was published, a man named Rowan Naidu, researchers at Harvard University, have announced an incredible discovery, a galaxy that is red 13. This means that this galaxy was left alone after the Big Bang, exists 200 million years ago, and as far as we know, galaxies take billions of years to form. The old calculation method is no longer effective. The second mystery is, not only are these galaxies incredibly advanced, and in what scientists call the Dark Ages, already glowing. Back then, there were only a few first stars at most. It has now been confirmed that it is close to 20 such very old galaxies, and in future studies, more may be confirmed. The researchers also found that at least 7 evidence for black holes. These black holes also existed shortly after the Big Bang, and they are too big. It can't be a young black hole. This poses the greatest crisis in modern cosmology. No answer yet. Except for doubts about the Big Bang itself, all theories about the expansion of the universe, the first matter in space, all theories formed. Observations on the red instrument and dozens of other theories are being tested. Is Hubble's constant wrong? You know, almost all theories about the Big Bang are based on a single observation. Now it may be proven wrong. Edwin Haber discovered in the 1920s Galaxies have velocities proportional to their distance. Stay away from us. His formula is equal to h and less than 0. This effect is accurately described. Therefore, the Hubble tree and the subsequent theory of cosmic inflation. The Belgian physicist Georges Lemaitre was born, then proposed the universe from a single point. The idea of starting the Big Bang theory is just a few steps away, the expansion rate of the universe. So it shows the speed at which galaxies are moving away from each other. Hubble's results were later double-checked and found to be correct. With the discovery of the cosmic microwave background radiation, new evidence has emerged. This also shows a clear pattern of expansion. Modern method, two-factor oscillation, to study the large-scale structure of the universe. It's getting better and better. And this is the first true, where the positive problem arises. Recent measurements show, depending on the measurement method or object used, the calculated Hubble constant contains small nitrogen. Significant difference. Further discrepancies emerged. These differences are called Hubble tensions. So far, common sense attempts to solve the Hubble tension have failed, but James Webb's latest findings may provide important clues. If our old theories are not fundamentally correct, then the measurement of the largest structure in the universe shows obvious inconsistencies, so it's no surprise. Does dark matter not exist? It's fascinating. Because of the problems in the standard model of the universe, it came early. When Swiss astronomers, when Keith observes strange motions inside galaxies, he noticed that the motion of outer galaxies and the known physics inside, faculty of dynamics, match. There must be some unknown function here. And that's how the concept of dark matter is born. Since then, cosmologists and astronomers have been building the origin of the universe, approaches to development and operation. Dark matter is being brought into this picture, but he is still an undocumented person. Real construction. It's said that dark matter, it was crucial for the formation of the first galaxies, because it acts as an adhesive, attracts normal matter, and holds it together. This idea, the first clumps of gas and dust are envisioned. Under the influence of a dark matter halo, accumulated more and more normal matter. Inside these dark matter halos, further condensation of normal matter, collapsing under its own gravity, and start to form stars, eventually form galaxies. No gravitational viscosity of matter. Normal matter will not be able to grow at a high enough density, gather, forming stars and galaxies on larger scales. The distribution of dark matter is thought to form the cosmic web, and the dark matter halo is an important node. This explains the massive collection of galaxies, such as galaxy clusters and superclusters. This network also determines the large-scale structure of the universe. However, observations of the large-scale structure of the universe, now it's causing more and more differences. Something went wrong in old calculations and theories. It seems that the universe is being viewed at every turn. Point this out to us. Goodbye to dark energy. What if dark energy is also a misunderstanding? It's being talked about as the driving force behind the accelerating expansion of the universe. Measurement display. The universe has expanded at an even faster rate for 5 billion years. This was originally the principle of the Big Bang. In addition to the accelerating expansion of the universe, evidence of the existence of energy has also been found in the cosmic microwave background. So, in a nutshell, we can say that dark matter gravitationally pulls galaxies gather together, and dark energy, through its repulsive effect, accelerating universe and separate them. But the existence of dark energy has not been proven either. There are even some cosmological concepts can describe the universe equally broadly. And there's absolutely no dark matter or dark energy involved. For example, by modifying some cosmological constant, as envisaged by the concept of M. Although it cannot describe the entire universe, but he can describe so many parts. So much so that alternative interpretations must be taken seriously. Since James Webb, showing the error of the old idea. New attention. B. Put it on a theory that has received less attention before. Imagine that. If dark matter and dark energy suddenly disappears from physics. It's like the Big Bang. What happens next? Currently, we don't know which old theories will become popular. And within a few months, what new theories will we have? Currently fully open. Large-scale structure of the Pandora cluster. James Webb has done it again. Spring 2023. Webb takes another deep space image. This image shows the Pandora cluster of galaxies. The galaxy cluster behind, due to the gravitational lensing effect, ancient galaxy, and the stars reappear in the four corners. Scientists have become accustomed to seeing very ancient and virtually impossible galaxies. But this image shows something else. It's a huge structure. It appears to be located behind a cluster of galaxies, if the preliminary measurements are correct. This structure is so massive, so much so that he might suggest the existence of a galaxy cluster. The only problem is that it's an ancient structure, too big, impossible to exist in a young universe. This is the next piece of evidence that the universe was 1.3 billion or 1.35 billion years ago. It looks like scientists used to use their models, very different from what theory predicts. What different researchers have come up with is not a new explanation. It's more and more tasks to solve. We may soon solve more and more strange discovery. We must hope more and more puzzle pieces will gradually appear only when we have as much data as possible. Scientists dare to propose new hypotheses. The current Webb mission is still too young. We cannot rush to new conclusions. Lentra from Ottawa, Canada. Gupta is the absolute rule, one of the exceptions. He proposed his extended cosmic week in 2023, period theory, and from his science, great recognition from colleagues. Gupta demonstrated dark energy, modified theory of gravity, combining the concept of a ring universe, enable a whole new era of the universe. Figures for 2.68 billion will contribute to the development of galaxies and stars, flowing out more space, and possibly explain why the universe matured 1.35 billion years ago and highly developed. We need more evidence to solve this crisis. James Webb's mission will take many years. But Webb, the cosmological crisis may not be solved alone. 2023. The European Space Agency has launched the Ulysses Space Telescope into orbit. Ulysses' mission was to create the first ever, the most perfect map of the universe. Scientists hope that he can provide work on dark matter and further clues of existence. Due to current reasons, Ulysses may also be used to test alternative theory from 2026. Nancy Grace Roman. Space telescopes will observe cosmic phenomena like a supernova and measure the expansion of the universe with precision. Verisilubin. The observatory is another one in the race. TechAce. This ground-based telescope will accurately reveal, shows the large-scale structure of the universe. Researchers hope to learn more about galaxy clusters, the formation of superclusters, and the role of cosmic filaments. Virahiru. The observatory will specifically look for gravitational lensing. These are basically all the very large objects in the universe. Due to their gravitational pull, they're like magnifying glasses. The telescope will be located in northern Chile, the 682-meter-high Mount Elpin. Spirac in Nassar, 2024. The mission will map the entire sky, explore the history of the universe. By collecting data on the cosmic background, Spiracs could help solve the current cosmological crisis. Make an important contribution, your understanding of the universe.